Hello, this is Darren Pulsipher, Chief Solution Architect of Public Sector at Intel, and welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology. On today's episode, we're going to talk about hybrid cloud storage with Director of Technical Marketing, Johan Ballin from Hammerspace.
Thank you. Glad to be here. Thanks, everyone, for joining.
Hey, I've had a lot of great conversations with Hammerspace over the last month and a half. I first seeked you guys out because I had some connections, but I really love your story around migrating my workloads between clouds and multi-hybrid cloud because of the great story you guys have around your global namespace and the way that you manage data across this really complex ecosystem.
Thank you, Darren. Yeah, we've taken kind of a different approach. Storage has been around for a long time, obviously, and what we've noticed, what is really ripe for disruption. Things are done in a very traditional, very cumbersome, procedural, and often manual and error-prone way. And our founders sought out to create data orchestration. Applications have become portable, but storage has really lagged behind. So that was the driver for creating this company.
Well, I remember when I talked to your CEO, David Flynn, it was really interesting because what he did was he disconnected the data, he abstracted the data away from the storage. And I went, whoa, this is exactly what I'm looking for, because I just want to access my data. I don't care where it resides, which cloud it resides in, on the edge, wherever it is. I just want to access my data and let the underlying system be smart enough about moving the data where it needs to be at the right time. And that's something you guys came up with, which is brilliant.
Yeah, there's an interesting story behind that. So David Flynn, as you mentioned, he was the inventor also of Fusion.io that created NVMe. And in doing so, David always thought he solved a performance problem, but he contributed to the silo problem. So he wanted his next venture to be something that solved the problem that he helped exacerbate. And that was the inception of Hammerspace.
Well, I'm glad he had that inception, because I see this as I really see this as a catalyst for getting that multi-hybrid cloud architecture that I'm always espousing here on the podcast.
So imagine for a second if your data were untethered from the storage infrastructure, free from the limitations imposed by storage. Your users could self-service their data management and protection, change the cost profile in an instant, access data from anywhere on any infrastructure without having to fuzz with the storage. It essentially liberates the what from the details of the how. Use software-defined storage to scale out performance on demand and deploy modern workloads such as Kubernetes on any underlying infrastructure anywhere. So the challenge really is applications have become portable, more and more portable due to the demand of delivering applications on a worldwide basis and to collaborate. But data is still siloed. So how can we solve that? Performance, reliability, and manageability all suffer at scale because of this silo problem. The solution is really to untether the data from those limitations of the underlying infrastructure. And it is metadata aggregation, essentially almost the anti-gravity of storage, the smallest constituent parts that we assimilate to make data portable. So essentially now wherever you go, your apps have on-demand data. Independently control the control and data plane. That's essentially what it is. And provide a global namespace and global file system that spans multiple data centers and clouds. Orchestration, to sort of follow the modern model of orchestrating applications. Why not orchestrating your storage, your data, to fully automate it and to leverage declarative autonomic data management? And that sounds like a lot of fancy words, but what it really means is, again, separating the how, declaring the desired end state without having to outline every single detail of how to get there. The system essentially figures it out autonomically, just like the autonomous nervous system. And to allow you to operate at a file granular level. So all of the controls are, you simply declare an end state. You don't want to lose the ability to do it at a very granular level. And to provide enterprise class data services tied to that data. Snapshots, clones, all the things that we have come to expect from any modern data management solution. And to much more easily operate, such as moving massive scale from data center to data center, from data center to cloud, back to data center, or disperse it in a hybrid multi-cloud scenario.
Okay, so what I'm understanding from this is you have disconnected the storage from the data, the management of the data from the applications. So you created this data management plane in the middle that presents up to the application layers, the abstraction, so I can access my data anywhere. And the underlying storage is managed from that data management plane. So this gives me all the flexibility that I want and also the controls that I'm looking for in that multi-hybrid cloud scenario that we're talking about. This is brilliant.
Thanks, Darren. And that's spot on. That's exactly right. To remove those controls so that you have high level yet granular control without having to necessarily understand every single detail about disparate storage implementations. So it frees those controls. Legacy storage essentially has become unable to manage modern challenges. It doesn't scale to and even the horizontal scale-out paradigm that was created to solve the even older scalability problems of scale-up solutions doesn't really scale in a cloud scale or planet scale world. Even those clusters eventually become silos, and you end up now with cluster sprawl instead of just array sprawl. You also cannot scale typically capacity and performance independently. So there's all kinds of constraints because of underlying infrastructure. So you end up typically with stranded capacity and or performance. You never can provision to make sure that you have just enough. You end up with too little or too much. Geography, data is still stuck in clusters. And even cloud can become a silo eventually. And nobody wants to be held hostage to a single vendor. Replication also leads to copy data sprawl because replication is an ancient technology. Instead of moving the smallest constituent parts, you're now moving the entire payload, all the data, often on the volume level. And data management is often an afterthought, and that is the problem. You want to put data management in the front instead of in the back.
Now, as you know, Intel, we have drives that we sell, right? Like our Optane drives and our 3D NAND drives. We like data sprawl, you would think, right? Because, hey, people are going to consume. I've got 10 copies of the same data scattered now in the cloud, in data center 1, in data center 2, on the other side of the country. I should be happy about data sprawl, but I am not, because I've experienced this myself. When you said, hey, I've got data all over, as an application developer, I don't want to have to worry about my data. I just want it there when I need it, right? And what people do is they make copies of everything everywhere. So this replication, even if it's in the underlying systems, still doesn't prevent application developers or data scientists from copying data around. And that's why I love what you guys have done here, because you've upped it to, hey, we're going to talk about data, not storage anymore, which I love. I think this is a brilliant way to go.
Thank you, Darren. And that's spot on. Because even, yes, it leads to higher consumption of storage, but all of a sudden you cannot find things. And you don't know which version is correct. And it has to have had some dramatic implications when there are different versions. Even in airplane design, both Airbus and Boeing, for example, have run into massive problems because such and such engineer did not have the most updated version. So versioning, finding data can actually lead to gigantic business problems. So the solution really is to orchestrate your data. That is our firm belief. And essentially, Hammerspace does for data what Kubernetes has done for applications, freeing data, making it independent of underlying infrastructure, mirroring what Kubernetes has done for applications, making those independent of limitations of infrastructure. So if we take a look at what data orchestration looks like, first of all, it is the decoupling of all the different silos, whether they're data centers, storage arrays, or clouds. You want to be able to treat all that data as a single pool. Assimilate the smallest constituent parts, namely the metadata. So you essentially now have that data anti-gravity system. Implement declarative statements that we call objectives, which essentially mirrors, right, in a business objective. And those can be things such as availability, durability, snapshots, tiering, you name it, or custom defined actions that can be done through Hammerscript. And finally, to make sure that data is portable so that whether it is Kubernetes, NFS, SMB, there is the ability to tie into the system. You don't have to go to another silo somewhere else to service a particular workload. And that makes sure that we now abstract and unite those silos, reduce the data gravity that's present, power workloads with business intent, and to orchestrate data with a global namespace, non-disruptive data mobility, so that you now have ubiquitous data delivered to where you want it to be. The data mobility is a key part because it's live. It is not data migration, which is disruptive, causing downtime. Live data mobility means that your data is live, similar to storage vMotion for those that are familiar with it, but even more powerful.
So I have a quick question because you say, data mobility, not migration. So are there any concerns about egress costs of the data mobility across cloud boundaries? And do you talk about your objectives here. Are there any objectives that I could establish to decrease my cost of egressing data out of the cloud? Because that's very expensive, right?
That's a great point. Yeah, absolutely. So data in transit is deduplicated and compressed. And it is done on a file granular basis. So let's say you're removing a certain data set from cloud A to cloud B. To minimize those egress costs, I mean, the costs are there. You can't avoid them.
No,
but you
can't.
can mitigate them. Exactly, right? So, but you can mitigate them by making sure that you don't move an entire volume that is fixed. You pick out the data you want to move, whether that is something based on a MIME type or a custom data descriptor, metadata tag, folders, it can be essentially any kind of expression of data you want to move. And that is done on a file granular basis, so you minimize those expensive egress costs.
So instead of moving a whole directory structure, right, from the data aspect, I can say, hey, I'm only going to use these files and only grab those files and bring them over when needed, right? And I don't need to move them beforehand. I can get them, like, for example, I spin up a Kubernetes service, right, with several different microservices that are going to work on a set of data. I could then ask Hammerspace, make sure that data is on this cluster, on this Kubernetes cluster running in-house. Instead of grabbing the whole directory structure and bringing it over, I can do it that way, right? I have that kind of flexibility.
That's exactly right. Let's say, for example, you wanted to move all the movies, and let's say they're MPEGs to make it simple. You wanted to move all the MPEGs, MP4s that contain corporate training. You want to move that from point A to point B. And you want to avoid moving things that are stored, for example, in end users' home directories, personal videos, what have you. That's very easy to create an expression for that. And there's three ways you can leverage objectives, either through the GUI, through the CLI, or a custom user-defined script. So that way you can make sure you only move exactly what you want. And again, it is deduped and compressed in transit to really minimize those expensive egress fees.
Now, you mentioned that we have a global namespace, the whole concept of the global namespace. So if I, for example, have, what's the right word? If I have an application running on in my data center, but I actually don't have a copy of that data actually physically in my data center, what happens? Is that automatically migrated or moved? What's the right word? I mean, how does that work for me?
That's a great question, Darren, and that's something that absolutely can cause a lot of concerns. A lot of people play around with the word global namespace and global file system, and when you unwrap it and peel the onion, it quickly becomes clear that it's not a global at all. It's unified or something else that's not quite global. When we say global, we mean it's addressable through a single name, whether it is a UNC path for SMB workloads or an NFS export. It's addressed exactly the same way for that piece of data, regardless of where the data is, regardless of where the application of end user is. And to make sure that we minimize the load on the WAN, so the metadata, of course, is what's distributed in that global namespace. So let's say, for example, I have an application in London that needs to retrieve data. It sees the data through that global namespace. The application views the data as if it is local. But let's say the data actually happens to be stored in Singapore. What happens from there on is that the data is moved over on a file granular basis to make sure that is the minimum drain on resources. So you don't have to replicate data. You don't have to pre-position it. You certainly can, but it will trickle over file by file with full block tracking to make sure, again, that we minimize the load on the WAN or any potential cloud egress costs. So let's take a quick look at the Hammerspace architecture, because I'm sure everyone is curious what this actually looks like. So if you take a look at first the global file system, there's essentially three components from a high level. The global file system itself, the front-end presentation, NFS, SMB, a Kubernetes CSI driver that presents blocked file, as well as NFS shared storage. So plenty of choices for different workloads. And within the global file system, we have Anvil, which is the metadata management component, and DSX that provides the data services. And these can be implemented either as virtual machines, VMware, KVM, Hyper-V, all supported. And DSX, Anvil, I should say, should be in an HA configuration. So these two of them at each location that you want the global file system to be served out. DSX can be parallelized to scale out performance. So you can have a number of these at different locations to make sure that it has enough performance. And those can be scaled out easily. And of course, on the back end, the storage, the underlying storage, whose data we have assimilated, it can be our own software-defined storage with directly attached disk. It can be a NAS that we assimilate. It can be any cloud and a combination of all of them. This can also scale out horizontally. So now you can scale performance and capacity independently. And following the cloud model, it's also elastic. So should the business change at that particular location, you can scale back performance as well as capacity to make sure that applications have just enough what you need at that location. And that really makes up what we think is a very flexible architecture to serve any of the application workloads on the front end.
You know, one of the things I like about this flexible architecture is your ability to assimilate data that's being stored in devices that aren't yours, like NAS or in the cloud. That's really important, because if you were to come to me and say, "Oh no, we have to bring all your data, has to be in our own proprietary format," that just wouldn't fly, because that's really hard to assimilate things that are sitting in the public clouds. So
Right.
I really love this architecture, how it gives me that flexibility. In fact, I was talking to Dave. I said, one of the biggest problems that my customers have is even just having a catalog of where all their data is. I mean, that alone
Right.
is brilliant with this architecture, because I could just plug anything into it. And
That's exactly right.
it'll work pretty easily right out of the gun. So
yeah, I mean, imagine how much it simplifies moving data. For example, I have an older NAS and I want to migrate to a newer NAS. Whether it's different vendors or the same vendor, doesn't matter. We'll assimilate the metadata, move the data behind, and completely transparently to the applications, because it's live data mobility. The data is mobile. How it moves around on the back end is transparent to end users and applications. And that's really powerful.
yeah, that is. I can even think when I'm in the middle of like a hybrid cloud migration, right? I'm going to move this workload from on-prem to maybe an Azure cloud. I have to
Right.
schedule downtime for the next 2 weeks to move the data. With this, I don't, because the data is abstracted from the storage. So you don't really care where it resides anymore. It's going to happen, by 2 weeks, it'll be done and no downtime. That's brilliant.
We showed, as a great example, we showed to Citrix that we were able to move profiles in a Citrix deployment from on-premises to cloud while the profiles were active. So Citrix clients were
Wow.
up and running with applications running, not even a blip on the session, whether on the bitmap refreshes, the audio, or the application itself, while that was moving from on-prem to cloud. And that was a jaw-dropping moment for the folks on the call.
No, that's awesome. This is great technology, and I know a lot of our listeners will want to know, how can I play around with this? So help us out, Johan.
Great question. Thanks, Darren. So the easiest way to do it is to go to hammerspace.com. And on hammerspace.com/10-TB, and you'll actually see it from the front page as well, is a free trial where you can get started and use up to 10 terabytes on that license. You can deploy it in Azure, in AWS, or in Google Cloud. So that gives partners as well as customers a playground where you can get started, and anything above that, or if questions come up, we're of course available.
Oh, this is great. I'm glad we had this talk. I'm excited to use your tools and introduce you guys to some of my customers. Thanks for listening to Embracing Digital Transformation today. If you liked our episode, go ahead and give us 5 stars on your favorite podcast or video streaming site. You can also find out more on embracingdigital.com. Until next time, keep moving forward and embrace the digital revolution.